Hello everyone. In this MATLAB and control systems tutorial, we will learn how to define transfer functions and how to compute impulse responses of transfer functions in MATLAB. So let's start. First of all, let's explain how transfer functions are defined in MATLAB. To do that, we will use an example of a second-order system. Everything explained in this tutorial can be straightforwardly generalized to higher-order systems. In the general form, a second-order transfer function looks like this. W of s is equal to, in the numerator, we will have a2 multiplying s2 plus a1 multiplying s plus a0. Here, a2, a1, and a0 are the coefficients, and s is the complex Laplace variable. What you can see over here is the second-order polynomial. Similarly, in the denominator, we will have b2 multiplying s squared plus b1 multiplying s plus b0. b2, b1, and b0 are coefficients of the polynomial in the denominator. To define this transfer function in MATLAB, first of all, we need to define array. Let me just undo this. To repeat, to define a transfer function in MATLAB, first of all, we need to define two arrays or two lists. The first list will store the coefficients in the numerator. That is, the coefficients of the polynomial in the numerator. I will call this list as num, and it will be equal to a2, a1, a0. And in the denominator, we have a similar list, and this list will store all the coefficients of the polynomial in the denominator. They are b2, b1, and b0. Now, to define this transfer function in MATLAB, we use the function tf, and we simply provide as the first argument the polynomial, or better to say the list, storing the polynomial coefficients in the numerator, and the second input argument is a list storing the coefficients of the polynomial in the denominator. That is den. And that's it. This function will return a transfer function object. Okay, let's now explain how to do this in MATLAB for a particular example. Let's assume that the transfer function looks like this. S squared plus 2s plus 5, and in the denominator we will have 2s squared plus 5s plus 4. Now, let's proceed with defining this transfer function in MATLAB. First of all, let's define the list storing the coefficients in the numerator. This list is 1, 2, 5. The list or the array storing the coefficients in the denominator is 2, 5, 4. Let's define our transfer function, tf, num, den, and the output is a transfer function object. Here it is. Let's see this transfer function. Here it is, 2s 5, 2s squared plus 5s plus 4. Next, let's compute the impulse response. To compute the impulse response, we use the function impulse, and let's see the output. Now be patient here, and let's see the output. Let me just close the previously defined windows. So I will repeat this, and here's the output. This is the impulse response of our transfer function. Now, another thing that you would like to do is to extract the actual values of the impulse response. That is, to extract the time series of the impulse response. You can simply do that by specifying the output of the impulse function. I do it like this. The vector yi will store the computed impulse response, and ti will be the use time. And then you'll simply type impulse of w. And after that, you will see in the MATLAB workspace over here yi and ti, and that's it. And then you can simply plot again these values. To do that, I will simply here call this impulse as figure 1, and then in figure 2 I will plot the actual computed impulse response. And let's compare these two graphs. Here's figure 1, here's figure 2, and they're identical, as you can see over here. Okay, that's all for today.